Hello everyone, welcome back to the channel, and today we are going to solve maximum sum with at most k elements. So here we are given a 2D integer matrix which is grid of size n cross m, in which we have integer array limits as well, which defines maximum elements which we can consume from each particular row. So if this particular grid has two rows, then the limit will also be the size of two, because from this particular grid we can consume one element from this grid and two elements from this grid as per this limits array, and we can only consume maximum k elements. That means here we can only consume maximum two elements from the entire grid, such that we have to maximize all the picked elements summation. So we have to maximize the summation of all the picked elements. We have to consume at most k elements. We have to maximize the summation as well. So let's understand this by a simple example. So here we are given a grid which has two rows and a limit of size 2 as well, with k defined as 3, which is the maximum number of elements which we can pick. And we have to maximize the summation of all the picked elements. Okay, so it's obvious that if we want to maximize the summation, we will obviously pick the maximum valued elements. So it's obvious that if we want to pick only three elements and we want to maximize the summation of all those picked elements, then we will obviously pick this 8, 6, and 7. For that, let's sort this array so that we can know what are the maximum elements. So we will sort it in reverse order. But here, keep that in mind that we are given a constraint with this defined limit array. So let's consider that as well. Let's define consumed elements here and define limits here. For these two rows, we have how many elements consumed until now. So we have consumed zero elements from now. But let's define the limits as well. So for first row, we have 2 as a limit, that we can only consume two elements from first row, and we can only consume two elements from second row. So now let's sort the array to see what are the maximum numbers which we can pick. So by sorting, we will get 8, 7, 6, 5, 3, 2. So if we want to maximize the elements, the summation of picked elements, then we obviously have to pick all the maximum numbers from this way. And we are only allowed to pick three elements here. So let's pick these three elements. Okay, but we have to verify that are we following the constraint here? So let's see. If we pick this 8, which is in present in second row, then we have to see, are we exceeding this particular limit? No, I think we have only picked zero elements until now. So we are allowed to pick this 8. So let's pick that and include it in our maximum sum. So let's define our maximum sum here and include that 8 there. So now we have consumed one element out of this total limit of 2 for this second row. Let's move on to the next character, which is 7. Can we pick 7 here? Okay. So the limit here is 2, and we have only consumed 0 elements until now. So we can obviously pick 7 here. So let's include that in our maximum summation and update our consumed elements counter. Okay, what is the next maximum element? Which is 6. 6 is present in second row. Can we pick 6? Obviously we can, because we only consumed one element out of the total limit of 2. So let's update our limit to 2 and include 6 to our maximum sum. Okay, so we also have to keep an eye on how many elements we have consumed until now. So we have consumed 3 elements, which was our total size of k. So I think we have picked k elements. So we will return this sum as 8 plus 7, which is equal to 15 plus 6, which is 21 as an answer. Let's go to another example to make it more clear. So here we are given a grid of size 3 cross 3. Let's consider 3 as a row and 3 as a column, which is m cross n. We will consider this in a code. So let's define our consumed elements as well as our limit. So initially, our consumed elements for row 1 will be 0, row 2 will be 0, and row 3, it will be 0 as well. But our limit will be 3 for first row, 1 for second row, and 1 for our third row. Okay, so here, let's sort all the elements here to determine what are the maximum values which we can get for our maximum sum. So initially, our maximum sum would be initialized as 0. And let's sort this entire grid numbers. That would be, okay. So this is our sorted order of all the grid elements. Let's go through one by one. Let's pick the maximum available number, which is 9. Can you pick 9? from this grid? I think we can because we have only selected 0 elements out of the total limit of 1. So let's update our maximum sum, include 9, update our consumed elements to 1, and move on to the next maximum available elements, which is 8. Can we pick 8 here? Okay, so here we cannot pick 8 because we have already consumed all the available elements from this limit of size 1. Okay, so we have to skip this element. There is no choice we can pick this element because of this limit constraint. Okay, so let's go to next element, which is 7. Can you pick this 7? Okay, so we have consumed 0 elements out of the 1 limit. So we can pick this 7 as well. So let's include it in our maximum sum and update our consumed element counter. Okay, what is the maximum available element? Maximum available element next is 6. So can we pick the 6? Okay, we have already consumed all the elements from this particular row. So limit was 1 and we have consumed 1 element. So we cannot pick 6 here. Let's skip this 6 and move on to the next maximum available element. The next maximum available element is 5. Can you pick this 5 here? Okay, so consume element for first row is 0, but we have a limit of 3 here. So we can consume this 5. So let's add it in our maximum summation. Okay, so right now we have picked total 3 elements, but we have to pick 4 elements. So let's move further and let's see what is the maximum available element. So that is 4. Can we pick this 4 here? I think we have a limit of 3. Okay, we forgot to update this. We have a limit of 3 and we have total consume element from this first row as 1. So we can pick 4 here as well. So let's include that 4 here in our maximum sum. Update our consumed elements to 2 and check if we have consumed all the 4 elements. Yes, we have consumed total 4 elements. So what will be the summation of this 4? We just have to return that. That would be 25. So we will return this is as our answer. So what we have done so far? Let's summarize that. So first, we have sorted all the numbers in reverse order so that we can go through all the maximum available numbers from the grid. Here, keep that in mind that we will be requiring which element belongs to which row, such that if we are going through our maximum available elements. Let's say we are going through 9. We have to know that the 9 is present in which particular row, such that we can update our maximum consumed element for that particular row and check for the constraint with our limit. So for each element here, we'll also be tracking their corresponding row, such that for this is present in third row, this is also present in third row. Similarly, the 7 is present in second row, 5 is present in first row, 4th is present in first row, third is present in first row, and such like that. So that as soon as we encounter any particular element, we have the information about the element present in which particular row so that we can update our consumed elements as well as check with its specified constraint of limit. So first step was to sort all the elements in reverse order. Along with that, we will also be requiring that particular row's information, that element is present in which particular row. The next step was to pick the maximum valued available number and to see if we have consumed all the elements from that particular row in which the element is present. If not, we will include it in our maximum summation and increase our consumed element pointer for that particular row. So here we have two steps. First, we have sorted all the elements in reverse order with the rows information for each particular element. Then we will go through elements in reverse order such that if we have encountered the maximum available elements and we will see if we have already consumed the maximum available limit for that particular row. If yes, then we will skip particular element. Otherwise, we will include it in our maximum summation and update our consumed pointer for that particular row. If we have consumed all the key elements, we will return our maximum summation. So let's move to the coding part. We will do a variable declaration for our numbers array and along with that consumed elements for each particular row. Then we will collect all the numbers from our grid and then we will do sorting such that in reverse order so that we can go through first index and check for our constraint that if we have consumed all the elements for that particular row in which the number is present. If not, then we will include it in our maximum summation which we are going to return. Otherwise, we will just keep that element. Okay, so let's initialize our variables first. So first will be our numbers list, which we will consist all the grid elements. Then we will initialize our consumed elements for each particular row. So our row would be m and our column would be n. So let's initialize that. So for each row, first we will initialize our consumed elements as 0. So 0 for each row, right? Okay, so then we will accumulate all the numbers from the grid. So for all the row and for all the column, we will accumulate all the grid elements. Here, consider that we have to include its row information as well, so that when we are going through this numbers list in sorted order, and when we found if this particular grid element is present in which particular row. So for that, we will also include its rows information. Here, the row of this particular grid element is I. So we will include that in our numbers list so that we can easily check for that particular row if we have consumed all the elements or not. So by this way, we will include grid element along with its row information. Then we will sort all the numbers in reverse order. Now, for each maximum available element, we will check. Here, keep that in mind that this grid is consisting of total m cross n element. So our numbers array would be of size m cross n. So while going through all the numbers, we have to keep the size in mind. Let's initialize our maximum summation from 0. Okay. So we also have to initialize one consumed total consumed elements so far so that we can know if we have already consumed k elements. If yes, then we will return what is the whatever is our maximum summation until now. If not, then we will keep counting it in our maximum summation. Okay. So now let's say for numbers present at in okay. So element which is present at numbers index I. First we have element and its row information. So we would have number and its rows information here for this particular element of our numbers list. We will check if we have already consumed elements for this particular row. Our limits is this. So limit will include its row information. So this limit. So now we will check if we have already consumed all the numbers from this particular row. For that, we will check if consumed elements for this particular row is less than its limit. If yes, then we will just keep this. Otherwise, let's say if it is less than it, then we will include it in our maximum summation. We will include the number in our maximum summation. We will also include that we will increase the total consumed elements count. Along with that, we will also increase the count of how many elements we have consumed for this particular row. So we have consumed one element for this particular row. Otherwise, we will just keep continuing. We will check if we have total consumed elements equal to k, then we just have to return the maximum summation until now. Otherwise, we will keep counting it. We also have to check one base case that if we have k is equal to 0, that means if we are not allowed to choose any number, then our maximum summation would be obviously 0 here. Otherwise, we will check for each number if its consumed elements are less than its defined limit. If yes, then we will include that particular number in our maximum summation, increase our total consumed elements along with consumed elements for that particular row. If we have already consumed all the elements for that particular row that is defined by its limit, then we will keep continuing and see for the next available maximum valued elements. Okay, so let's check if this works or not. So here, this was a small mistake. Okay, so this is working. Let's check. Okay, so as you can see, this is working fine. Let's check about the time complexity. So this particular iteration would be of time complexity O of m cross n as we are iterating through whole grid. This particular sorting operation would require us the time complexity of O of m cross n and log of m cross n because the size of this numbers list is m cross n such that the time complexity would be O of m cross n log m cross n. The next iteration of this particular numbers list would require us O of m cross n as well because we are iterating through all the elements in numbers and the numbers list size is m cross n. So this is a simple m cross n operation. So our overall time complexity would be O of m cross n into 2 because we are going through this O of m cross n twice plus O of m cross n log of m cross n. So this will be our cap. So overall time complexity would be O of m cross n into log of m cross n. Let's find out the space complexity here. So here we have consumed elements list, which will be of size O of m because we have this consumed elements defined for each particular row. So that would be of size O of m. Again, we have this numbers list, which would be O of m cross n because it will consist all the grid elements. So the size of numbers list would be O of m cross n. Other than that, we have this constant, which will be just consuming the constant space and will not occupy any space. So overall space complexity would be O of m cross n into 2. So that would be finally O of m cross n only. So this is our final code, which you can say this is working fine. So let me know if you have any doubts in the comments. That's it. Thanks for watching. Catch you guys in the next one. Peace.